Okay, I'm going to start early because this is the introduction. So, welcome, good morning, and I'm Walter Berendsohn. I'm kind of looking after your timing of the talks, etc. You also have some devices here that tell you exactly when you're overtime, which I don't hope. And I'm still, in spite of the short time, I'm asking all native speakers that they slow down with their presentations. I've heard some presentations here. My English is not bad, but I had real difficulties following because it was like that. So please, better leave out a slide and talk a bit more slowly. Okay, so we're talking about globally linking taxonomies. There was yesterday the species, not species 2000, the Catalogue of Life Symposium, where we already had quite a lot on that topic. For those of you who couldn't follow that, I recommend looking at it later because there will be the movies on in YouTube or something like that. Okay, we're coming to our first speaker, who's Sarah, and she's talking about Catalogue of Life in Taiwan. And yes, please.
Thanks, Walter. Thank you, everyone. Can you hear me? Okay. Good morning, everyone. I'm Sarah from the Taiwan Biodiversity Information Facility, TaiBIF. I am a data administrator and mainly manage the database TaCo. It's the National Species Checklist database in Taiwan. Today, I'm very happy to share with you our recent progress. My topic is implementation of taxonomy name usages in generating national species checklists in Taiwan. Okay. Taxonomy name usage refers to the entry of a scientific name cited in the reference, reflecting the author's taxonomy perspective in literature. Because the same scientific name might have different viewpoints in various references. Preserving this information helps present a complete taxonomy history. So these are the terms that have appeared in the past and are related to the concept of TNU. This list comes from Dr. Pyle's presentation in 2022 TED Week. TNU documents the author's taxonomy views, including the use of scientific name, classification, and status, like accepted or not, indicators like sp.nov. And citation to express similarities or differences with other authors' viewpoints. Additionally, textual information in literature, such as native or introduced status, habitat, and common names, also reflect the author's perspective or research results. On the other hand, the cited type specimen, other examined specimens, and distribution also present the described subject or community or entity in the author's viewpoint. All of this information can be linked with TNU. The TaCo scientific name management tool, abbreviated as TaCont or simply name tool. This is the place or tool we developed mainly for recording TNU. If you want to learn more about the name tool, you can visit the website or check the slides I presented last year in the TED Week. About the goal, the original TaCo is a plain checklist and cannot accommodate different views of taxonomy. Therefore, we use the name tool to record TNUs, which means storing many checklists, just like checklist bank, I think, but in local. After integrating the TNUs, we obtain a consensus checklist following the latest reference. We can also have different taxonomy views of checklists in the future. How do we do it? First, we retrieve all related TNUs. Then we group TNUs with the same accepted name and group TNUs with the same protonym, autonym, and other homotypic names such as replaced names or spelling variations. If a new name is added, we check again until no additional names need to be joined. We also handled misapplied names by identifying that the citation listed after a misapplied name is actually another TNU from other reference. Okay. We incorporate this to make the taxonomy history and related information more complete. For local use, since we often cannot obtain complete misapplied history, we incorporate TNUs with earlier publication year if both sites are labeled as exist in Taiwan. Both approaches are used in our process. After grouping, we determine the latest TNU based on publication date and literature type. The literature is prioritized in this order: the taxonomy literature, then checklist, then backbone. The checklist, the type of reference, the checklist refers to unpublished references, such as lists announced by academic communities, research reports or theses, and government documents. Then we check the names one by one for reasonable taxonomy, ensuring that homotypic names are assigned to the same taxon group. In this step, we check if homotypic synonyms occur in more than one group, except for misapplied TNUs. If this happens, we check the latest TNU and merge the earlier TNU into the group with the latest TNU. If the homotypic earlier TNU is accepted, we merge the whole taxon group. If not accepted, we merge only that TNU. After merging the homotypic names, we check if there are more than one latest accepted TNU in the group. If they are parent and child, that usually happen within the same reference. If they are parents and child, the rank relationship, we separate them into two taxa, as they are both accepted taxa in different ranks. Similarly, if an infraspecies as the latest accepted name in the taxon group includes its species rank, we separate them. On the other hand, if a species as the latest accepted name in a taxon group includes its autonym, and we check if any reference accept the autonym and no reference merge them, we also separate them. Then we verify the result by returning to step 4 and 5. And finally, we design the type of update for the taxon and record it in the taxon update history, which includes updating accepted names, adding or deleting scientific names, and adding a new taxon or deleting a scientific, or deleting or reviving the taxon, or we merge or separate them, or add or new or delete common names, or adding references, etc. The update history will also be displayed on our website. The processes described above have been implemented, and the results have been pushed to the TaCo portal. We continue to review the accuracy of the checklist results and make corrections based on users' feedback. Here, I would like to summarize the advantages and disadvantages of using this method. The advantages include, number one, our tool preserves taxonomy history to provide diverse taxonomic perspectives. Number two, reduce taxon redundancies through using the relationships like homotypic synonyms and misapplied names. Number three, we provide literature sources of names and properties, allowing users to know their origins. Number four, offers more reliable and stable taxon ID for users. As for the disadvantages, number one, there are so many TNUs that need to be entered, more than species, many times more than. Number two, if the original combination are not fully established, it may lead to taxon duplications. Number three, most people who have assisted in revising our checklist in the past have complained that the new system become too complex. So we need to consider some compromises. For our future work, we are considering ways to make data input more automated, such as through AI assistance to make the TNUs entered more quick and automatically. Number two, making the original combination of existing data more complete. Number three, continuing to increase the utilization of name tool through the educational activities or providing relevant guidance and resources. And we exploring collaboration with the academic communities more. Okay. I would like to thank the Forestry and Natural Conservation Agency in Taiwan for their project funding support, and also express gratitude to those who participated in the initial work, domain analysis and development. Thank you for your attention.
Okay, any questions? Online question? Okay.
So there is a question from Alan Stenhouse. Do you have an online DB of taxonomic and reference literature for searching?
Yes, the name tool that I just mentioned, it's a website that we stored scientific names and reference and even persons that for the reference author and the scientific name authors. The tool, the website is for you can search and you can also manage the names and the taxonomy name usage like TNU all in that website.
Yes, please.
Hi, I'm Shotaro from Japan, and I have a question about how to say the merging the taxon concept. Usually many taxonomic paper get a conflict about taxonomic concepts. So sometimes some taxonomists validate species A, but some taxonomists synonymize the species A. So in that case, how did you decide to which taxon concept should be accepted in your the merged checklist, national checklist?
Thank you. And so actually we choose the latest reference to
latest. I see.
Yeah. And we will integrate all the TNUs. That means integrate all the reference that they're different. They might have different taxonomy viewpoints, but we will choose the latest one for we need to show the public that we want now we use this. But so we show the latest checklist in the website, in the portal of TaCo, and want to. We will do. We'll find out a way that to help people to use in the different concepts, different taxon views checklist.
Okay, thank you very much.
Thank you. Another question? Andreas? No. Okay. I have a little final question. How many names and how many taxa are you dealing with?
About scientific names in the old version of TaCo, we have about 160,000 names.
Yeah.
Am I right? No. 160万吧。1,000 哎。160万 1.5 million 1.5
million
names and about 60,000 taxon.
Okay, thank you. Thank you. Okay, we're coming to the next speaker, I think. That's Heimo from Vienna, and he will tell us about the specimen information system, JAC.
Yeah, thanks for the organizers of the symposium to accept my contribution. I'm dealing a little bit with how we curate in the JAC system, which is a system, centralized system, where people from multiple institutions can enter and manipulate their collection holdings, and how we do this scientific name stuff. So the botanical collection in Vienna is an old one, dating back to more than 200 years. It's global coverage, and it deals with all plant groups, plus the traditionally curated groups in botanical collection like fungi, algae, and today's Chromista or cyanobacteria and other groups. So we need to deal with the names and partially also with the taxa for these groups curating. The JAC system currently encompasses 60 institutions, mainly German-speaking countries or European origin, but also 2 from South or Middle America. 17 countries. What you see here is the distribution of the legal institution or units like universities, museums, botanical gardens, academies, research institutions, and we also have 1 monastery in Austria which holds interesting collection when it comes to Italy and historical stuff. We have currently about 2.2 million specimen records, of which we produced 2 million set of stable identifiers, so a system developed in Edinburgh and then applied to the institutions in participating in JAC. It's about 34,000 collectors which are not disambiguated currently, and it's 250 countries also mentioned here. It's also including countries that don't exist today, like Yugoslavia or other regions in the world. We are contributing for 15 institutions from 7 countries. We're contributing to GBIF, and we are also part of the fair sharing repository cited. What you see here is like how we interconnected with certain external services like Wikidata, BHL, Set of Stable Identifier topics, BioKISS, and so on and so forth. What we were dealing in the beginning is classical literature. So we needed to go back to systems that have been printed. Here is just mentioned Bromid and Powell, or Bromid alone, families and genera of flowering plants is used for the arrangement of the phanerogamic collections at the Natural History Museum, but many use still the old Englerian system published in Dallatore and Harms, but also Endlicher, Durand, even older ones, and Saarbrückner is a system for the lichens, and Detoni for the algae groups. And then, of course, the online resources appeared. One of the early stuff was Tropicos, but also Catalogue of Life, and of course IPNI. What you see here is 2 services which already have some possibilities for reconciliation, which is the Q and the World Flora online databases. So this is, I will talk about this a little bit later. But then we also stick, of course, to regional systems like Antos, which is a very heavily scrutinized system for the Iberian Peninsula. So talking about Spain and Portugal. Reflora is dealing with the Brazilian names. So there have been 700 specialist taxonomists engaged in aggregating nomenclatural and taxonomic information. So this is really serious stuff that we need to do. One of the topics that we are digitizing currently in the Natural History Museum, all the Brazilian holdings, so there the Reflora stuff gets important. But there's also smaller ones like the Flora of Cuba, or big ones as well as Flora of China or AVH in Australia. What we have in the system is like we have taxon names atomized. So we divide the units of the string of a name. We add the rank, then we have the uninomals from genus and above. We don't do subgeneric above species level information separately. And then we have species epithet, species author, infraspecific epithet, and infraspecific author. Why we include the basionyms is because we did a big Mellon-funded or funded project, the Global Plants Initiative. So we needed to do the basionym reference anyway, also for the names used in the collections. We have different groups of users of running the JAC system, and one is dealing with setting up the lookup tables, which is in this case, a selection only for the names. So what they can do is they can add, update, complement the existing name base. They can do it on a singular basis, so individually, manually editing and introducing new names, but this can also be done bulk-wise. I will show this also afterwards. And then they can still make references to taxonomies based on resources and classification systems. Some of them I've shown before. And then technicians and digitizers, they make use of these names. So this is not, people are not entering their strings, but they select from the lookup tables. And of course, it's used for label printing. How did we do this? So we query and download names from external services, for instance, from IPNI, Topicos, Index Fungorum, and else. We atomize the download according to the SHAC system. We include the reference ID and the name ID. And then we compare this to the SHAC system, utilizing Tony Rees's matching facility. Then we populate the database of SHAC with names that already exist and match 100%, or we add complementary names, including same external ID and reference system. The old workflow was to do it manually. So we went to the webpage of IPNI, we searched for a species or for any taxon, can be families, can be genera, whatsoever. Then we downloaded it, we atomized it, we compared it against SHAC system, and then we imported the identifiers or the names themselves. Current workflow is we're using OpenRefine and reconciliation services. So we produce out of the SHAC system or from external sources, we produce a list that we send to the reconciliation service using OpenRefine, but is again still static. So we do it on a bulk or case-by-case logic. This is how it looks currently. So we were very happy when we found out about the GNA names verifier. You should read it from the left to the right. So we have a list of names that we are reconciling against the service. We get back what is in the databases. So then the rightmost column gives the complete result. We then select individual identifiers, in this case only IPNI, GBIF ID, Catalog of Life ID, and WorldFlora Online ID. And what we then do is we have a small routine where we can check the system's result against SHAC entries. The code is on GitHub, and we visualize the result. So all the light green marked rows and lines, they give a name that can be imported in the way it is. So a genus name is checked against the genus name entry in SHAC. The epithet is checked against the epithets that are added in SHAC. The author abbreviated again according to the IPNI standard, so on and so forth. In the third last row, you see the identifier from the VFO, and we select the reference. We have about 60 references, generally speaking. So the green ones can be imported. What you also see is red marked fields, which is in this case an epithet. This does not occur in SHAC. Sometimes we check it against the original source. Sometimes we just import them. But what you also see is, like, if an author does not match, or in this case an author is missing, there's a WorldFlora Online entry where the author is not coming or has a problem, maybe also a technical issue in the comparison, then it's shown red. So you need to clarify these problems. The lowermost stuff is then visually separated by marked in blue, and you see the references. You can go out to the reference in the service, or you can go inside in the SHAC system and check it out. What did we do and when did we start? So this is a list of the institutions. It's generally, it's comprising 18 institutions where names authors were contributing in the aggregation of these names. You see the timeline, it's 20 years effort. The results, we have more or less 450,000 scientific names included, of which 9,000, approximately 35%, have been matched to external services. And for the 2.1 million records, we used 227,000 names with the identifiers. So 77% of our collection holdings are linked to outside sources. The top 10 I give here, this is GBIF, IPNI, Europlant Med, and so on and so forth. Future workflow will be that during the data entry of the specimens done by technicians, we try to integrate these external services dynamically. So once the name is started to be typed by the technician, it should already check the external services, so there's no manual download needed anymore. And the next steps and goals will be to complete the names catalog for all the groups that we are housing in. This is true only for the Vienna Herbarium of the Natural History Museum. Catalog for plants, phanerochamic plants are almost done, but then we go to the cryptogams, which is fungi, lichens, and all groups of algae. So we want to have all the envelopes that are used to keep this material listed in the catalog, which this can be folders, this can be capsules, this can be any labels on jars and stuff. And then we have implement online live feed from the Tsai names for the SHAC system, which is internal use, and provide services then for external query to external users. We try to do this until 2027. This would be the 300th birthday of Nicolas Chacun. Walter, so I had for a long time, I didn't have any name for the system, and Walter was suggesting Vienna and Chacun, this goes together, so why not just simply name it Jacques? This is the person when he was rector of the University of Vienna. Left-hand side is the museum building, natural history. Right-hand side is Schönbrunn Gardens, and right on the bottom is the university. So this is the three classical institutions in Vienna, and we will try to celebrate something. Maybe not as beautiful as this bouquet in the center. This was an homage to Chacun, putting together all the individual plants that he described. What you see on the lowermost left-hand side is some sources which could be queried already for Jacques and for Chacun, and we try to unify this sort of. As in one of the previous slides, so Jacques is registered in the fair sharing org system. What you see is a one-hop graph, how Jacques is integrated. This would be a three-hop graph, and Jacques is like just a small dot on the bottom right. So this is how I envision a little bit the position of these collections that we are curating. This is the names explicitly mentioned that do the names entries, and I thank very much the organizers again for the symposium, but also for Tedrick. And coming here, Okinawa was a dream for me, so I like it to present it. Thank you.
Thank you, Heimo. We have time for a question still. Yes, Marcus?
Two questions, actually. Have you experience with the stability of the identifiers that you link? Because you seem to store them. So is there any experience in if they keep on being stable? And kind of second thing, how is the experience with the GNPass results? The matching itself, is it like, do you get any false positives? Is there any troubles or?
Stability is a good question. So what we did is in the beginning, we linked not to taxon names, but to biographical references like botanists or in various systems. Harvard botanists, but also there's a biographical lexicon in Austria. So these names have been quite stable, let's put it this way. I did not start checking the catalog of online services before it was not published that the new identifiers established a few years ago will be stable. So before that, I did not include them. What I cannot do is, and what I cannot say is currently is checking if the content is the same. But it is our string is the same. So what we would need in this case also is like compare if the string that we have internally is the same as externally. What we also keep internally is the timestamp when we did this check and when we did the data entry. Therefore, I was showing the timeline from 2004 going up to today. Second question?
Quality of GNPass results, or if there's any issues, you know?
We see, since this is our daily business, we see quite some stuff that was necessary to adapt a little bit. So quality is, some sources are very good because you see, like therefore I mentioned also Anthos. They checked everything. So Anthos is really a very good resource. But linking out this again, so the linking out to the external services points the users to it. So if we want to show if there's a difference of what we have, we scrutinize all the names internally. So we could show what we have found internally and then to just visualize what's the difference. But it's less than 5%, maybe 2% or something of the names have really problems.
Thank you.
Zero.
Yes, we had 0. We have an online presentation now. How this is? Yeah, can you put it on? Yes. So Roger Hyam is going to be live, or is it a? Okay, it's a video. Okay, so welcome to Roger. Perhaps he's listening and can answer questions later. We hear about the taxonomic name linking system in Tetris.
Hi, I'm Roger Hyam, and I'll be presenting on taxon name linking services. I'm sorry that none of us on the paper can be with you in person at the moment. It would be great to discuss these points that I'm going to raise face-to-face in the corridor over coffee. I will be around each afternoon Okinawa time online, so please reach out to me or ask some of my colleagues who will be around how to contact me. This is also the start of a project, so it's a bit annoying that I'm presenting provocations rather than results, but I think you'll find it useful, or I hope you'll find it useful. I'm going to make 2 main points in the talk, and I'll highlight those when I get to them. I should place our project in context, especially for people outside Europe, who often haven't heard of the organisations and the acronyms that we throw around. CTAF is the organisation that ensures the experts in the many institutions around Europe that hold around half the world's specimens are talking to each other and finding ways to work together. Most institutions are maintained, at least in part, by national resources, but this rarely covers wider collaboration, which is where EU funding comes in. The EU's major vehicle for funding science and innovation is called Horizon Europe. Now, Tetris is a project funded by Horizon Europe and coordinated by CTAF. It's a €6 million initiative running from 2022 until mid-2026. Its aims is to improve how taxonomy and systematics is done in Europe. VLIS, which is the Flanders Marine Institute, and the Botanics proposed the taxon name linking service as a third-party project because neither of us as institutions are actually in the Tetris project, but they have a fund that they fund external projects with. Our little project runs from May this year until just for 18 months. So none of what I've just said really describes what the project is about in meaningful terms, in non-administrative terms. But if we look at the 4 main tasks of the project, it becomes somewhat obvious. Each of them has name matching in it. The project is about name matching. We aim to define some common parameters between the different name matching services that we run and support the wider adoption of those name parameters. We also look at having some kind of taxonomic notification service, though I won't touch that in this talk. This talk kind of comes under task 2.2 and 4. We're kind of showing support for name matching services that exist, why you should do it, and also we'll move on to enabling those services. So if the project is all about name matching, we ought to talk about what we mean by name matching. And this is probably my first main point I'm going to make. Matching is not the same as searching, but we often confuse these two things. And I think if I can make this as kind of my main point of the talk, I'll have succeeded. Matching something that produces a normative response, and a normative response is prescriptive. It's something you must do. People who read the W3C data standards will be familiar with the fact that they have normative sections, which you must follow, and informative sections that are just to help you understand the normative sections. When we do a search, we expect a informative response, something to help us understand, but not necessarily something to say that is a definitive answer that we must follow. So matching is normative, searching is informative. Matching is binary, it's success or failure. You either succeed in matching something or you don't, whereas we talk about precision and sensitivity when we're searching for things. Are we getting, of the possible results, are we getting a significant amount of them? Also with searching, we talk about relevance. So the order you're placing on Google, how far up does it come, the result you're looking for come on the Google thing? Whereas that's irrelevant in matching because it's a binary result, yes or no. Matching is usually about a single accepted result from controlled vocabulary. So you are matching against something, against a particular vocabulary, and you know what that vocabulary is a priori before you do it. Whereas when we're searching, we're usually just going across a corpus of documents, the entire net or a library or a book or something like that. And often searching is what humans do, whereas matching is much more what a computery process that we want to do for computers. And from this you can see the classic examples, like if you look up in a phone book, remember when we used to have phone books, if you look up someone's telephone number, you find their name, you find their number. It's a controlled vocabulary of specific things that you're going to seek and retrieve that particular value. If they're not in the phone book, or if it's the wrong phone number, it's failed. Searching is a Google search. Yeah. So it's pretty straightforward. But because we don't differentiate between these two things, often people will talk about name matching as if it were searching. Name matching, you can do it once and it's kind of sticky, whereas searching, you can get a different answer each time. If the data changes, you get a different answer, whereas matching, you tend not to. So there's a lot of confusion around this. And one of the main confusions is that they both fall back and copy each other. When we're matching, if the matching fails, then we start searching. And also, we can use searching to help us look up a value and treat it as prescriptive. So you could Google for a paper and find its DOI, but that's not the same as matching using Crossref or something. This illustrates the difference between matching and searching with the results from the matching tool on the WorldFloor Online API. So on the left, we have matching results where we have searched for Solanum lycopersicum L, the tomato you should be throwing at me. And that is an unambiguous name string, and matching has succeeded. And you can see it's matched to a single WFO ID. On the right, it shows the results where I haven't included the author string. And here, matching has failed, but we have fallen back to searching. So the algorithm is suggesting two candidate names. At this point, the algorithm isn't matching anymore. It's searching and just presenting the user with two names, and the user is going to do the matching. So although it's a single name matching algorithm, it actually just provides a convenience relevance search. Indeed, this algorithm, if it fails any further, will present 100 results with a relevance rather than nothing at all. And some people find that awkward and some people like that. So it's difficult to please everyone. You can try this for yourself if you want to give it a go and see how that algorithm works at list.worldfloraonline.org. We've got a matching tool there for matching plant names. It also contains OpenRefine integration, implements the W3C reconciliation service API, so you can integrate it with your OpenRefine workflow if you need to. This is the second main point I want to make. The process of combining data currently starts with matching of the name strings used in each data set. So studies often contain names that cannot be unambiguously matched, like in the previous example I showed you, or some names are missing entirely. So it will always fall back to human interaction at some point, where we go from matching to searching. This is at least 10% in all the data sets we come across. A colleague was very pleased, I was speaking to yesterday, because it was 30% in the data set he was working on, and he thought that was quite good. But a large chunk of the name strings, when you're trying to combine data, won't match. And this is just very consistent, and you can't fix it automatically. With small data sets, it obviously doesn't matter, and before we were using computers in a serious way, when we were just doing or if you're just doing a PhD study on a few hundred taxa, then it's not a problem because you can work through it manually and make decisions. But it effectively makes combining large data sets or multiple large data sets impossible, because every time, every combination is adding 10 to 20% error. So the only way you can overcome that is to push the name matching process back to the original studies, only match them once, and then keep a handle on the ID of the name and combine the studies with the IDs, because you can only, IDs match or they don't match. So we need one for each domain you're working in. We have agreed lists, control vocabularies of IDs. And I think that's why we called the project the Taxon Name Linking Service, even though it's mainly about name matching, because it's about moving to a point in the future where people don't tend to type names in. They tend to pick them from a drop-down menu, and internally an ID is stored. Externally, we present a name string for a human to consume, but the name string isn't a useful piece of data, and we need to move to that world. So this concludes my talk. I'm sorry I can't be with you, but I'll be available in the afternoons, probably about midday, 1 o'clock Okinawa time onwards and into the evening. And you can contact me online somehow. Drop me an email or through the conference system. I'd like to say thank you for your time and your attention. Thank you to the funders who enabled this work. Thank you to all those people who create the data that we just pipe around from place to place. And I hope to see you another time.
Was almost direct exact. So we're coming to the next speaker, Dmitry. And we are looking at reconciliation with using OpenRefine, which was already mentioned twice in previous talks. And here we have the presentation.
Hello everybody, thank you for inviting us to do this talk. What we want to talk about is, can we standardize name reconciliation tools using OpenRefine? Scientific name reconciliation is important for many biodiversity projects. There are tens of millions of scientific names in the wild. However, scientific names do have issues. Many of the names are synonyms of other names. There are spelling variants of the same name, and there are a lot of them. There are misspelled names, and there are also invalid names or not names at all. And gladly, there are several services that help us to reconcile these names. There is Global Names, Catalog of Life, GBIF, TNLS, World Flora Online, NCBI, and Binomial Nomer. All of them help to reconcile names in different ways. And these tools are complementary very often. So it would be great to be able to change from one tool to another. So reconcilers are not really fair to users in a sense like findable, available, interoperable, and reusable. And interoperability is a problem. You cannot easily substitute one resource with another. So we can find a fair solution, and one way of doing it is to write a program that would normalize input, send this input to whatever service people decided to use, get results, and then this program would normalize output again and give it to the user. And actually, such a program already exists. It is OpenRefine. OpenRefine has a standard input and output. And what we can do is to write an adapter for different reconciliation tools. And then we can use them interchangeably in OpenRefine. And additional bonus, OpenRefine is a popular tool used widely by data managers. So what is OpenRefine? OpenRefine allows you to clean and transform and connect data from different sources. It is very powerful, and if people use it on a daily basis, pretty soon they find that they cannot live without it. OpenRefine, for example, can resolve scientific names, or it can resolve geographic names, or it can resolve people. So it is very, very nice and powerful tool. So let's look at the case of a co-author of this talk, Amanda. She is a librarian, and she works with biological texts. For example, she has 1,600 observations in this particular text with 500 species, and she needs to make sure that these names are correct. So how can it be done? So what Amanda wants to do is to find scientific names in these texts using another global names tool called GenFinder, and then use a global names verifier to reconcile these names against different data sets. However, she wants to do it using OpenRefine, and at the time we did not have OpenRefine connection of global names verifier. So she wrote, I think on Twitter, that she has this problem, and David Shorthouse was kind to convert this report from Amanda to a GitHub ticket that we eventually saw and started to work on it. So what is global name verifier that Amanda wants to use? It is a tool for reconciliation. So you send a list of names of unknown quality, and you get back results where these names are matched against reliable data sources. There are more than 100 data sources in the program, and 30 million name strings. There are quite sophisticated match algorithms, fuzzy and partial match, match by authorship, taxonomic name resolution, and finding a name taxonomic status. In spite of so many different algorithms, the speed is quite good. And what we did, we developed connector between GN verifier and OpenRefine. And using this tool, it is now possible to take a list of names, enter global names verifier URL that tells OpenRefine what to use for reconciliation, and then get results back. And this is great. However, it is not enough. For example, for Amanda, it was good to know what data source was used to reconcile against. It was good to know what is classification of the name, what is the current name, and we were able to use OpenRefine to find all this data. So, for example, we can find all data sources where this name appeared. We can find canonical form of the name. We can find classification. We can find what is currently accepted name for this taxon. We can find what data source was the best to reconcile. And we can find outlink so Amanda can go and see this name in the best data source that we found. So how did we implement this? We used OpenRefine Service API. It is a standard that is used by OpenRefine, and if you implement it, you automatically become compatible with OpenRefine tool. And we are not alone who did that. Wikidata has it for a long time. Also IPNI, Workflow Online, and GN Verifier, they all support this API. As a result, right now it is possible just to change a URL and use any of these four to do reconciliation. However, we want to go beyond basic reconciliation. So OpenRefine Service API provides extensions format, and we can use this format to provide all this additional data. And also, we can use input flags to filter results, for example, by only mollusks, or for example, only by catalog of life. And these extensions, they're great. However, there is no standard in OpenRefine how to normalize them against different sources. To do that, we would need to agree on a format of inputs and outputs for this additional information. And if we're able to do that, we can create a powerful, fair ecosystem of name reconciliation. And we can go beyond OpenRefine using the same API, because it is possible to write additional programs that will use this OpenRefine in new ways, and how Nikki Nicholson mentioned that OpenRefine is only the first step in using this API. And that's all for this talk. Thank you so much for attention. Special thanks to David Shorthouse and Nikki Nicholson for encouragement, ideas, and general help. And the moral of this story: if you have a problem, add an issue to GitHub, and maybe your problem will be solved.
Questions?
There's not a question, but a remark from David Fichtmüller. who says that an information reminder for all the OpenRefine users in the room. Currently, the 2024 OpenRefine user survey is still running, and then given an URL. After completing it, you are shown a link where you can prioritize or suggest new features that might be implemented soon. Let the developers know how they can improve or to better fit your needs. So there's maybe some possibilities.
Okay, thank you. We have some time for further comments. I don't know. Do we have Dmitry online or?
I'm here.
Okay, that's good. Do you have any plans to actually do something like a TADWIG subgroup or something like that to go further with your idea of harmonizing standards? I think that's a great idea. I'm working with OpenRefine, and I find that I get very different results from different services linked to OpenRefine.
I think it would be wonderful for people who do use OpenRefine for reconciliation to be able not to do only basic reconciliation, but also like if they want to know more details, these details are coming from different resources the same way. That would be great, I think.
I would, if nobody else wants to comment, we have some time. I'd actually stick to the basics first, because in the very simple, direct name reconciliation, I already get very different results from different providers. So something like a documentation of what's actually provided by the service and how the matching that is effected works behind that would be very useful from all these services. Anton?
All four, like Wikidata, IPNI, Workflow Online, Global Names, they all have documentation that describe that service. So
I'll ask you later about that. Anton?
Yeah, Anton Günch, Botanic Garden, Berlin. I just wanted to make the comment that there is actually a working group in TADWIG, or interest group, I don't know, working on, or which is supposed to work on standardization of APIs and services. I forgot the acronym. I happen to be the convener of this group, and I have to admit it's totally inactive. Like 3 or 4 years ago, we were enthusiastic about it, maybe 5 years ago, but somehow, I mean, I would be really happy if somebody would now stand up and try to reanimate this group, because I think it's central to not only for the name matching purposes, but for the service infrastructure in general, that we agree on certain principles. It would help us so much to bring us forward with integrating services and all this. I don't have the capacities to bring this really forward, but if somebody younger and more enthusiastic would try to do this, I think it would tremendously help. Thank you.
Sorry, Anton, I hope you realize that I didn't really see that. And I think a specialized group would be very good. Lyubo?
I had a question regarding the output. For the sources that you do get kickbacks from for the taxon references, does that include the taxon ID for that given reference or references?
If it exists. Sometimes, like for example, for Arctis, ID is a canonical form of the name without authorship. So that creates some problems. Some sources have multiple IDs, so we have to pick one. And sometimes people want not that ID that we pick, but other one. So like, it is something that would be great to receive feedback and work on it. As I mentioned, making tickets in GitHub sometimes really makes wonders.
So sorry, I may have not been clear. So like for like I call it IRMing, IRMNG. That one, each taxon has a ID number. For those resources that have ID numbers with their taxon listings, if that comes up as a result, does that get kicked out with the spreadsheet? So like in my database, I have the ability to add my taxon reference and the taxon reference ID number. Does that come out in the results?
It can. Like in global names verify proper, it comes with as a part of the result. Nobody asked for OpenRefine. We will add it as by your request. Pretty much.
Great, thank you.
Just a short comment that those minutes of that TEDWIC working group on standardization of API was used as a basis for further development in Bicycle through several meetings of Bicycle partners, also external partners like David Shorthouse and Nick Nicholson, and we published those guidelines on the Biodiversity Knowledge Hub. They are not final, but they are really a step beyond what has been granted to TEDWIC and should be continued. But there is already a document about standardization for biodiversity API.
Thank you, Heimo. Okay. Actually, we have to proceed, and I hope I can take the liberty to introduce myself. That's the next presentation, please. So coming from a use case we've seen for a zoological treatment, I have a use case here for a botanical case, and it's herbarium systems and the names in herbarium systems. Actually, a name in a collection, not only herbarium, is something that's maybe really be thought of as an index to the content, to the store of physical things. So we have to look at that this is a double function in herbarium and other collection information systems, that it's for the physical sorting and physical finding of physical objects. And so it's not necessarily, or mostly actually, it is not up to date. And it might have been updated, but it might also not have been updated. And there are several things there that can influence the naming of the specimen and the names that are attached to it. It's a bit different in a digital collection of specimens, where we actually make that into a part of a global infrastructure. And so the problems become quite different. And that's why I also always tell people, if you digitize your collection, you're creating a new collection that needs data curation and on a long-term basis, additional resources. So the Tetris project we've heard already about is trying to connect local taxonomic data resources of different sorts to global aggregator or aggregators in general, and in this case, how we're going to link herbarium names to botanical name aggregators. So why should we do that at all? So really, we are interested in first to find out if our name has been used on the aggregator side and if it's in the same form. If we find an exact match in one of these aggregators, we can actually get additional information about our name. Might be nomenclaturally incorrect or things like that. So we get more information. For the unmatched names, we first get a list, and then if we sort it, we get, for example, those names that have a number as a first character are clearly to be corrected. I mean, this is an example. This is not something I'm inventing. So there are lots of things in databases that accumulate over time, and so we can easily find things that are not matching because they are nonsense. But there's also, there are these things that might match, and that was mentioned by Roger already. We have this candidate or potential matches thing, and there we can actually compare our name with some perhaps matching names. And we might find things on our side with misspellings, incorrect authors, etc. But we also might find things in our community aggregators that need to be corrected or added. And we've heard they're not complete. We heard yesterday in the Catalogue of Life Symposium that for plants alone in Workflow Online, there were large amounts of names added over the last year alone. So plant names have a certain advantage. It's a small group. Well, it's a small group compared to other groups in organisms. We have a quite well-defined code with clear rules. Our names are in some respects less complicated than zoological names. And we are working on catalogs of names for a long, long time as a community. And so it's now really the time to say a global and complete catalog of names and what we call designations, which are things that are not really acceptable according to the code, but that are actually have been used as names in a taxonomic context. It's achievable to actually get a complete catalog together. And problems in exact matches are, and here we have the advantage of these author abbreviations, which are highly standardized and almost everybody adheres to them. But then we have these little things that some people put a space in one place and some in another place, and we have a standard, but these little things make exact matching for a machine, in the first instance at least, complicated. Then we also have to say our code is not really exact in everything. So prescriptive things for how to put a hybrid marker or put it at all or use notho or things like that. We have this X author issue. Look it up if you don't know what it is. And we can have autonyms that are with the author in between or without an author, and some put them even incorrectly in the end. And in the end, we have orthographic variants, and we have different classes of orthographic variants. We have what I mentioned initially, real bad misspellings in a herbarium database, but I'm talking about those things that have been used already as designations in a taxonomic context. And of course, the first publication that, according to the rules of the code, can be corrected is one of these variations that probably, well, that definitely has been used in a taxonomic context. So all these things, including also later ascribing a name to a certain author, is possible as a thing that can actually cause problems. And some of these things can be corrected or mediated on the aggregator side by, for example, eliminating all spaces in a name before comparing it, and other things have to be done locally. Well, just to have an impression of I wanted to get an idea of the size of the problem, and GBIF is aggregating a lot of herbarium data sets, and it compares these with a rather pragmatically put together set of names. So we can say it's a very broad name resource. Here are the botanical sources that Marcus, thank you, gave me. And well, if I look at the names and the matching process in GBIF provides the original name, or they provided me with the original name coming from the herbarium or the botanical aggregator, and the interpreted name. So I just look, where do we have these exact matches and where we don't have it? And well, at the first at first view, it looks a bit frustrating because we have less than a quarter that initially match directly. It's a bit better than it looks because these things like things that can be done on the aggregator side are not really accounted here. But it's actually that more than 2/3 in some cases of the names in a collection don't match to anything in the GBIF catalog at a first step. They manage to match it to lots of things afterwards, most of them correct, some of them far out, but that's not what we want. We want to have the exact match to get exactly this ID connection we have, but that was mentioned before. So yeah, there's room for improvement, and I wanted to make a little excursion here because Roger actually didn't make much of a promotion of World Flora Online plant list. I'll leave this, you can look it up later in the file. I think this is going to be actually this global resource, and that's for plants, and it's really making a lot of headway now. Okay, what are we doing in the Tetris project? In the context of the article we are writing, we are going to match the records from our herbaria. We are going to suggest measures for collection information systems that are used or more widely used. Some of these institutions are using JAC and one specify how these collection systems could already provide something that can directly feed into OpenRefine or into the name matches that are online, especially the one from World Flora Online. And we can look at what can we do to actually improve exact matching. And for example, cutting the spaces out of the author teams and just comparing the rest already brings up the number of matches to nearly 30%. And if I look at the 70% that's remaining, it's mostly that people provide canonical names without author from herbarium databases. So that can also be quite easily be corrected if there's no homonymy involved and things like that, if we have a complete source. And of course, how to improve the aggregators is a very important point because it's not all the fault of the herbaria. There's quite a bit of problems on the aggregator side as well in the name matching mechanisms, but also in the data that is there. So what we're doing is actually we have a wish list for aggregators on our wiki, and that's growing not every day, but every week, I'd say. And if you have any suggestions, if you're yourself playing with aggregators, also in general, not only botany, please let me know. And we will also see that the impediment that consists of having no personnel for data curation at the source can perhaps be made a topic in one of the coming World Flora Online councils where we have the directors of several or many institutions sitting that should pay attention to this problem. Thank you very much. Questions? Marcus?
Maybe the 30% or those little exact matches in GBIF I'm surprised to see and would be interested in how you got to the number, because what is the exact matching that you used to?
Well, I got the download from GBIF that was provided, and the exact matching is actually the literal matching of the string that's coming in with a string in the database. So wherever
with
that
spaces, with any
spaces,
character.
everything spec, SP, indet, all that stuff plays a role. I've already looked at the data, so it's not as bad, but it's, if you go as a user to the matching tool and want an exact match, you don't get it. And so the moment you don't get an exact match, you have to look at things. And if you're looking at a herbarium database that has thousands of records, you can't do it anymore because it's just too much. So we have to improve this exact matching folder to come to the real problems in the end that might be missing names on the aggregator side or real misspellings on the herbarium side. But we have to reduce that problem, and I think that's the main point I wanted to make.
It might be helpful to try OpenRefine with Gen verifier. Like some of the things that you said, I think they go automatically.
Oh yeah, I mean, I'm doing that. It was just trying to illustrate the problem. And as soon as curators, data curators in herbarium, who are not specialized, if they're actually confronted with having to sort out more than 70% of their names, they probably don't go about it because they don't have the time. So we have to somehow facilitate that, and having automation in OpenRefine might be a solution. I don't know. So this is work in progress. It's time for the next presentation. Do we have that live? Actually, where are my glasses? That is an important point to me.
One comment.
Okay.
Just came in. I think it's a comment only. Alan Stenhouse again. I'm aiming to develop AI-based multi-agent systems to assist us with some of these data curation issues. So keen to learn more.
Great. So we're coming to the next talk, which is online, and we have a certain change of topic. Actually, in the first talk, we already were talking about concepts a bit more. So the rest of the presentations will focus more on the concept question and not so much on the name question, although the name question, of course, always is a kind of initial step to that. So please.
Hello everyone, my name is Elisabeth Hüllbusch. I work for the German Federal Agency for Nature Conservation, and I'm happy to present you today our checklist API, which allows you to query taxa and their concept relationships from German taxonomic checklists. Why do we need such an API? Biological data refer to taxa of a certain taxonomic concept, and people usually use scientific names as unique identifiers for these data, for example, in databases. However, the taxonomic concepts to which these scientific names are linked to often change over time, while the scientific name may remain the same, or space. For example, if a species name refers to different infraspecific taxa in different regions. That means that scientific names alone are not sufficient to unambiguously assign research data to the taxonomic concepts on which they are based. Our approach to solve this problem is to represent taxa in their relationships as a semantic network, then choose the applicable taxon within this network, and then assign data and taxon names unambiguously to this taxon. Although there already exist different data models that allow taxonomic concepts to be represented and linked, such as the Berlin Taxonomic Information Model or the Common Data Model of the EDIT platform for cyber taxonomy, we found that there are hardly any interfaces that can be used to effectively access taxonomic concepts and their relationships. To address this problem, we developed the checklist API. This is a public machine-to-machine interface which allows you to query taxon names, taxa, and their concept relationships as well as synonyms from the checklists maintained at BFN. Those checklists comprise the checklists of the national red lists for more than 80 species groups, partially with synonyms. The checklists are maintained in BFN's checklist system, which is a computer program that allows us to create and update taxonomic checklists. The system automatically documents taxon relationships and concept relationships between taxa across checklist versions. Here the main types of concept relationships in the system are shown. The red circle symbolizes taxon A and the white circle symbolizes taxon B. Now the first one is congruence, which means that the two taxa refer to the same populations. Then inclusion means that one taxon includes all populations of the other taxon plus additional populations. Pro parte inclusion is the opposite of inclusion. This means that all populations of one taxon are included in another taxon plus additional populations. Interference means that the two taxa only partially refer to the same populations, and exclusion means that the two taxa do not refer to any overlapping populations. And the last one is total exclusion of one taxon, which means that this taxon does not refer to any part of any population referred to by taxa from the other checklist. There are actually a few more types of concept relationships in the system, which are shown on this slide. I'll leave those for you to read later because I won't go through them now. Now the next question is how to query data via the API. For this, I'll open the Swagger documentation site, which looks like this. First, you get some general information about the API, such as the terms of service and the license. Then the methods of the API are shown, and at the bottom, the models of the response are listed. To show you a simple query, I've recorded a short video, which I will show you now. We'll start by searching for taxon name. For this, we go to the get method taxa by name. Can expand this by clicking here. And then the site lists all the parameters for this method. Then I click on try it out, so the input fields become activated. You see that there are many optional parameters, and actually only one parameter is required, which is the taxon name. So I put in the input field my taxon name of interest. This is the name of a diatom species, by the way. And then I click on execute to get a result. Now the site provides us with a request URL, which we can put into the browser to get the result. And the response body of the site is also shown here. So this is the result in JSON format. We chose this format because it is a common data format to save and transfer structured data, which is used by many web applications. Because the JSON format is uncomfortable to read, I put the result exemplarily into a table. We got the following research. The result, the name Calanase bacillum was found 2 times in the system. In both cases, it is an accepted name. We get a taxon ID for each taxon and a URL to each taxon, which we could use to call further information on each taxon, and we get a checklist ID. So we see the name was found in checklist number 70 and number 71, and for each taxon we get a UUID. Next, we go back to the API to find out how these two taxa relate to each other. Again, this is shown in a short little video. To find out about concept relationships, we will use the method taxon relationships. Again, I can open this by clicking on the header and click on try it out. Now this method asks for the taxon IDs. And I've copied them from the response before and put them into here separated by a comma. Click on execute. Now the result looks a little bit different. We get relations and hierarchies, for example. Again, I put the result into tables. So now we got the result that taxon A is smaller than taxon B. And the API also tells us which taxon is taxon A and which taxon is taxon B. For better readability, I noted the result like this. Calonaeus bacillum in checklist 71 is smaller than Calonaeus bacillum in checklist 70. Now we can stop querying further data, but instead think about how to use the result. From this output, we could either decide that assigning information to taxa is problematic because the names are ambiguous, or we could choose the applicable taxon to assign the data to. My colleagues from the NFDI for biodiversity are currently testing the API for this purpose and can answer questions regarding this. I'd like to thank NFDI for biodiversity for funding, my colleagues Anto and Katja and Andreas from the Botanical Garden in Berlin, my former colleagues Gerhard and Rudolf. Gerhard actually developed most of the concepts for the checklist system, and Falco Riemenschneider from the company Doctronic, who did all the programming work. Thank you very much for your attention.
Well, we don't have Ellie online, but we have Anton and Andreas here in the audience to answer questions, if there are any. Marcus?
Just curious how the relations are established. Are they computed or manually assigned?
Yeah, as far as I know, they are partly computed, but also managed manually, because the relationships are mostly relationships between different versions of the checklist, like the older red list backbone and the newer one, and they developed also this Doctronic, this company, they developed a system to really come from one version to another one and to establish the taxon relationships while they are doing this step. So this is really done manually and somehow automatically. So, and it's not so many taxa because it's only for Germany and not worldwide.
Sorry, just what and the API has a function or parameter where you can choose that the system is traversing the whole graph, which belongs to a certain taxon. So you don't have to do this yourself; it's calculated.
Any further questions? Well, maybe I could add something that actually this use case of red lists has greatly influenced the thinking about the necessity for concept and concept mapping, because here we have a real relevant issue if taxonomic concepts change over time and you get a new version of a checklist that is a red list and has a legal status, etc., then, well, you might have a problem. So this is a real use case for the relevance of name relationships, pointing out where there might be problems, where to ask a taxonomist, as I always say. Okay, we can already come to the next presentation, which is Andreas Müller from Berlin. And you found somebody who can take over there. Okay, great, Andreas.
Hello, I'm Andreas Müller from Berlin Botanical Garden, and I want to talk about a taxonomic concept mapping service that we are currently designing for the use in WorldFlora Online or for generally taxonomic information aggregators. So some words about WorldFlora Online. We have heard about WorldFlora Online already, so I think most of you know it somehow. It's a flora with a global scope, and it is intended to achieve the target 1 of the global strategy for plant conservation. It has about 50 consortium members already, and it's growing and growing. So it's a global and quite large initiative. How does WorldFlora Online aggregate data into their system? So in short, it is 2 steps. The first step is creating the backbone, which Roger is actually doing together with his colleagues from Edinburgh and together with all the taxonomic expert networks that provide the data, and some other providers like IPNI and World Checklist of Vascular Plants and Q and so on. And in the second step, which is the one that is I want to look at, content is added, and the content comes from content providers all over the world, and it's mostly based on regional floras and so on. So how does this work? If the taxonomic backbone of the content providers is actually the same as the one used in WorldFlora Online, we don't have a big issue. But usually this is not the case. So there must be some algorithm how content is added to WorldFlora Online if this is not the case. So the algorithm is relatively easy. If the name that is used locally or in the regional flora is the same as the accepted or exists as an accepted name in WFO, then we just move the fact from this same named taxon to the according taxon in WFO. But if the local provider uses a synonym, a name that is a synonym in WFO, then we first have to check the accepted name in WFO, and then we move it to the according taxon. This is simple, but it creates problems if, like here, the backbone is not the same. So, for example, here we have taxon. There's a split in the global version, and you can see if you follow the algorithm, the fact is, or the content is only moved to one taxon, but we could argue that it should be moved to both taxa. And also there is some doubt to which taxa, if it's not, it shouldn't go to both taxa, to which taxa it should go. So here more an example that is a bit more theoretic or abstract. Again, let's say we have 2 species, and the delimitation of the species is a bit different in the local and the global version. Then it is relatively easy to move the content from a smaller taxon to a larger one, but still there is some doubt because there could be exclusive information like this taxon is endemic in Japan. This might not be true if the taxon is larger, and then it's maybe not any more endemic. In this case. So even more difficult is the situation where the taxon is covered by 2 taxa, or at least partly by 2 taxa in the global version, then as we have seen already, the content should go maybe to both of the taxa, which is currently not the case. And also we again have this kind of doubtful or this questions about if it's really going there or should really go there, or if it's only about a part of the individuals covered by this taxon. So the current approach is actually, it's good because we have a large database and we need simple approaches, but we are missing some data. And mostly this is the case when content should go to multiple taxa, and we are missing this doubtful information that we just cannot resolve because we just don't have the data. So consequences might be that users get confused if they compare the global and the local version, or they can compare two local versions like neighboring countries, and they come to different results, not because it's really a different situation, but just because the taxonomic concepts are different in these 2 regions. And therefore, for example, the protection status of a taxon is different in the neighboring country, and that creates confusion. So decision makers even may come to wrong decisions based on this information, and some interested users may just simply wish to understand the relationships between the backbones. Or in other words, what do we want to do? We want to fill the gaps in the content. We want to add information about shortcomings of the data, about doubtful information, something like this. And we want to show relationships between taxa. So what do we need for this? We need some kind of taxon relationships. And we have already heard and seen by the question from Marcus and so on, this is not so easy to create taxon relationships, especially not in such a big content. Like maybe in Germany, where we have a lot of history about creating, manually even creating taxon relationships, this is still kind of possible, but in a global context, and when you compare completely different backbones, it's difficult or impossible actually to create taxon relationships that are really based on taxon circumscriptions, because this data is simply not available, or the data is the parameters are very heterogeneous that you need to compute to compare. So you can't do this automatically. And manually, it's just the task is too large, so it's not feasible. So what is the way that we want to go? This is based on just comparing synonymies. This is a proposal or an idea that Rich Pyle talked about 2 years ago in Sofia on the TEDWIC meeting. And the main ideas here are that we can use synonymies because names stand for type specimens according to the nomenclatural code, and type specimens do have well-defined characteristics, even if they are not described explicitly somewhere. But experts who created the backbones, they might have looked to these characteristics if they were relevant, and they built up the backbones on top of these. So, yeah, why is it using synonyms is much easier? This is because data is, in the given use case, this data is often available. Definitely it is available on the WFO side, and often also on the local side. And it's much easier to compare only one parameter type, which is the name, than to compare multiple different parameters. So how does could a workflow look like? First of all, we group names by what we call homotypic groups. So we group them by types, by their types, because not each name has a different has an own type. Some names have the same type if they are only recombinations or new names or so. Then we do the name matching on top of these groups, but we don't have to match like really each name, because we could also input the information from the groups, from the grouping. And then what is the most important or interesting part here is we can do the taxon mapping just by mapping the homotypic groups and see how they map to each other. And here it comes that the traditional taxon relationships are maybe not so important anymore. What is more important is the cardinality of the relationships. So if we want to aggregate content, then this last case is the really most important one, the one which is important for deciding that content is going to 2 taxa, not only to 1. The above thing is also like showing some conflict in the backbone, but this is already there in the current version, because yeah, I think I don't have to it's not so important to say why, but yes, so I would like to go up to this, the traditionally included one, maybe again. This is definitely happening quite often, but just because the World for Online, of course, has much more names than a regional checklist. But as long as they're not creating conflicts, actually, like the ones shown here, the red ones, then this only creates a small doubt, because it only says, okay, there are names used in a different region of the world, so it's not really critical. So we store this information, but it's uncritical information. Yes. So this is, in general, an iterative process also, because once we know what is a critical match, and so we can go back to those name matches that didn't match, and we can decide, okay, this one we don't care about because it doesn't create critical data, but others that don't match and create critical data, then we have a look. We have to do some more work on this and try to create the match again. And there's a fourth step. This is the hierarchical aggregation. This is only the idea that once we have done this on the bottom level, like on species and subspecies level, we can easily aggregate it to the top, because type specimen belong not only to the lower level taxa, but also to the higher taxa, and the same thing can be done between these higher taxa also. So, final word about the requirements and the architecture that we are envisaging. So, yeah, the requirement, the main requirement is that we need synonymies provided by the content providers, which is currently not the case. So this is just an optional additional functionality, and this is also one of the reasons, many reasons, why we want to implement this as a standalone web service, which can be used but must not be used or for each of the content providers. And it should be not very much dependent on other functionality coming from World for Online. Okay, thank you. And questions?
Thanks, Andreas. That's very much what we like to do in Checklist Bang also, and I'm really interested in the completeness of synonymies, really, because that's crucial to identify the relationships, and especially if you map local national floras to a global list, isn't that very often the case? I'm just curious that synonymies are just incomplete, and then therefore you end up with this different concepts basically all the time, and also having what you said, non-critical ones, where you had this kind of split or like two types in one group, and then there's just one on the other side. Might that just not be because you're missing one of the other names? So in fact, it would be a split. You just don't see the other name because it's missing in the list. I don't know, maybe. Well, the main thing is, like, I haven't done it myself now with checklist, but I'm just afraid there's just far too little synonymy information available to really.
This might be true, but then, I mean, if you don't have the information, then you just have a concept which is not clearly defined. Okay, but I think most important is to show, I mean, we're coming from the use case and saying, okay, what information do we have to be able to improve at least a bit the current situation, to make it a bit better. So all the information we have is if the synonyms really have this kind of contradiction, that a taxon is really different to another one, obviously and objectively, then we can use this and create this or store this information. I mean, I don't know. It's just in design. We have not implemented it yet, so we may come to the result. It doesn't really work. So, yes, I think I expect that most of the data is either dirty data. This is a big issue to solve, but most of the problems that, like, local lists are smaller than like global lists. They are more based not on different taxon concepts, but more on, like, more names used in a different area. Like, I know from EuroPlusMed, for example, we store only European names used in Europe in the database. So it doesn't mean that the concept is different to the global concept, but it just means that we're just not providing all names. Yeah.
Okay, thank you. So now we're coming to the experimental part of, I don't know exactly how we're doing the Zoom presentation. Ah, here we are. Okay.
Cool. Can you guys hear me okay?
That's good. Yes, it looks good.
Okay, great. Great. Yeah, thanks for sticking around.
Actually,
okay, good. Yeah, is that working?
That's good
okay,
now,
cool.
Yes.
Okay, yeah. What a fascinating set of talks and really apt symposium it's been assembled here. A lot of synergistic topics, thinking about taxonomic concepts, and great opportunity to kind of be part of this conversation with you all, and seeing some familiar faces, Marcus and Anton, who I just saw last week. Really cool. So yes, this taxonomic data objects is what I'll be talking about, some work with Europe Poolin. And this is sort of part of a working group, this BAT Eco Interactions working group that actually we got started talking to each other during the pandemic and have kind of continued in collaboration with some folks at Arizona State University, where I am. And really sort of the way we've been approaching this is from this question-driven perspective of, okay, if we want to understand which bat species are interacting, for example, in order to try and understand something about bat and virus species interactions, we need to be able to aggregate data at this kind of global level. If we want to know something like which bat species are co-roosting in the same area, which might tell us something about the likelihood of sharing viruses, we really need to know something about, species according to who, right? We have this 200-year history of species observations in the literature, but we really need to get a handle on this concept level in order to get at these other questions. So you have this idea of one concept here with A, and you have a type specimen associated with that name, but then another worker could later come along with a different circumscription, use the same name. And so this, really common problem that you guys have all been talking about as well, right? This kind of sensu lato versus sensu stricto definition of the same species name. Another way of referring to this can be using these secundus references, the sec, author, which carries a lot of meaning with it. So this, according to, so name according to author, which, traces back to Walter Berendsohn himself. Really cool to have you leading this symposium. So 30 years ago, you had this great idea about the need to be keeping track of this information as potential taxa in databases. And we're still sort of, trying to figure out exactly what to do with that idea. We still need to implement it in a more explicit way. Sort of the history of that is, kind of traced forward through a variety of literature. This Lychee toolkit in 2000, Nico Franz, who I've interacted with a lot, picked up on this fairly early and is trying to propagate through the use of RCC5 alignments. That some of that has been talked about here. And then, but there's really sort of this question of, why hasn't why hasn't it been widely adopted, and why isn't it not kind of in the mainstream outside of TEDWG, for example, and perhaps social and technical reasons are responsible for that. We've sort of picked up on that in the last few years and thinking about this idea of taxonomic intelligence. How would we actually communicate things more specifically? And then I've sort of zeroed in on wanting to think about the species data, these like tangible items that come out of the secundus references. So I'll try and dig into that. And that's sort of the main argument of what I'll talk about, is that this is sort of an analog way of referring to a taxonomic concept, right? You've got Panthera leo here, according to some article, but inside that article are this concept information, like a range map, like specific DNA sequences that are diagnostic of that species as compared to a different one. Measurement data that pertains to specimens that are in museums, that it's been a referred specimen. This is that concept according to this author. We want to extract that information ultimately to create digital representations of it, and then use that to operationally translate biodiversity observations, such as those on GBIF or on GenBank, from one taxonomic concept to the other, to be able to test the impact of those hypotheses. So just an example of what I'm talking about here. One of the most, I think, kind of obvious and impactful examples is the North American deer mouse, Paramyscus maniculatus, that has 250,000 records on GBIF or more. It's been one species across all of North America for a long time. Oops. Let's see. But then in 2019, there was a proposal to split it into 5 species, right? So what does that do to the geographic observational data that underlies it? So one way to do that is to use the actual range maps, because they're reciprocally allopatric for the most part with respect to each other, and intersect it with the GBIF points using the coordinate uncertainty of those points. And we were able to relabel 99% of the observations using this approach, plus some machine learning for the additional ambiguous results. And so this ends up being sort of an inference using geospatial concept data extracted from one of those secundus references. And so we can continue to do this for a variety of taxonomic treatment articles. And so this is kind of using the workflow of Platzi in particular, of extracting taxonomic treatments, making those parts of articles open and fair, and then and then also working in the concept of ecological interactions with URIT in this context. And so kind of what we can do with that information once it's extracted is to create a digital signature of it and then use that signature to precisely communicate all the extracted parts as a taxonomic data object. So we can join those parts with, say, nomenclatural data. What is the type specimen? Where is it located? What's the type locality? And what we really want is machine readable versions of all these items. Could be accession numbers or links, but you could summarize all that in some sort of a README index file. This part of it isn't totally worked out yet, but you could actually have the actual machine readable versions inside of this in some sort of an archive, and then do a hash of that. That would be your taxonomic data object that you could use to send around, and people could know that they were talking about the exact same thing, right? So that confirm the digital contents of that data object for use in translating biodiversity observations in this way across multiple taxonomic concepts of the same name. And so really this idea, this is kind of what I mean about going from analog to digital, right? We have, both of these, the Secundus reference is also a content-based identifier, and it's a verifiable data citation in the same way that, like a librarian would use, right? You don't cite the library article, the library book by the place it is in the library. You cite it by the author, the name, the year, the publication title, the way we always have done. The issue here is that it's a human readable version as compared to what we really want is a machine readable version of that we can use in a scalable fashion. And so if you want to kind of dig into more of what we mean by this hash idea, those different algorithms, right? MD5 is most commonly used on the internet. SHA-256 is a slightly more robust, but these hashes end up looking like this. And Jörg goes into a lot more detail about this in his 2023 article. Just to kind of pull this together, right? So the main conclusions here are that if we want to be addressing these integrative questions, such as which bat species are interacting with which others or with which viruses, we need to be communicating the meaning, not just the names, right? I think that's kind of accurate aggregation is where we want to get to. The Secundus reference is a human readable analog way to refer to those concepts, but we can do a similar thing with hashes in a machine readable context and scale it up. So this is sort of, I'm presenting this as a hypothesis really, because we haven't done it yet, but that if we create these taxonomic data objects from multiple checklists, we'll be able to translate the same biodiversity data to multiple taxonomies in a scalable fashion, and then address questions in that context. So kudos to you all for pursuing taxonomic concept work, and I can take any questions. Thanks.
Thank you. Questions? Anton?
Hello, Nathan. I have an immediate question. I think there are many operations on taxonomic data objects which do not change the concept of this object actually, but would change the hash value definitely. So how do you deal with this?
Yeah, that's interesting, right? So yeah, I guess what I didn't explicitly say is part of the reason for the hashing is so that you can version the taxonomic concepts, right? So like as they get updated through time, and you can put the hashes, you register the hashes in some kind of a ledger. Blockchain is the idea that is commonly talked about. It doesn't have to be blockchain. It could be something more like GitHub, whereas you're just tracking changes. It wouldn't necessarily matter if it was like something small that changed, as long as you kept track that, this is the parent of that. But yeah, maybe as you just change one period or one byte in the object, it would have a different hash. But as long as you kept track of that, it wouldn't be a problem, I guess would be my answer.
Andreas?
But how can you then use these taxon concepts to compare two concepts coming from different sources? Because they are only exactly the same if they store the exact same parameters and parameter types and so on. That's what I wanted to explain in my talk, that this makes it really difficult. And if there are some small changes, it works maybe if you come from one version of the same concept, going to the next version, then you can deal it somehow. But if they come from different sources, I really wonder how to use these.
I guess it's in this context of, you're using this to send around the data, and then you still have to do the inference, basically, if you want to do the translation. The hash itself only allows you to verify the content, and then you have to unpack it and say, I mentioned the example with range maps, but with DNA sequences, you could do clustering, relative to, I'm saying that these sequences are A and B, and then you would cluster to all the other sequences that are related to that. Someone else might say that these other two sequences are A and B, right? So the inference occurs afterwards. It's interesting to see the way you guys have been approaching the problem from just figuring out the relationships between the concepts in a kind of abstract way. I guess this is really trying to make it operational as if you were a biodiversity state scientist trying to answer the questions.
Further questions? Yes, please.
Well, maybe it's more just a comment to what Anton just said about the hash changing when some small changes are made to the content of these objects. So what I think would be the way to avoid this is to abstract, to identify those potential changes and keep them separate of the content that is being hashed. For instance, if some dataset changes, you use an ID for the dataset, including the provenance, as it was, the timestamp for it, and that is part of the content that gets hashed, but not the actual data itself, which changes. Yeah. And in this way, it might be workable, at least more workable.
Yeah, no, I'm definitely, that's a really good point. Right, if you can have some sort of hierarchical way in which you would then start referring to the items. Yeah, I guess you could also hash each of the machine readable items, but then they would just propagate up. I don't know. Yeah, I feel like we almost need to diagram it on a board in order to figure out how to actually do it. But food for thought, and I definitely welcome any additional conversation on the topic.
Okay, thank you. I think we can conclude the session. And we can allow people to go to lunch. Thank you very much.
Cool.
It's very philosophical. You have to have something like if you basically go down to specimens, you don't need all this specimen was determined like this 5 years ago, it's determined like this now. You don't need concepts in this sense.